The topic of this talk is the POS framework, a methodology and toolchain for reproducible network experiments. This was joint work with my colleagues Dominik Scholz, Henning Stuppe and Georg Kalle. In the scientific community, everyone agrees that reproducibility is an important topic, and our community in particular has come up with the following solution. These are the ACM reproducibility badges. These are awarded to papers that go the extra mile and document their research in a way that others can easily recreate the original results. However, reproducibility in general has its problems. So there were already 2 workshops at the SIGCOMM conference that were dedicated to reproducible research. And one of them was back in 2003. One of them was in 2017. And the results of these workshops were that there are still problems, and there are quite a lot of overlap between the problems described in both workshops. So there was not much progress over these 14 years. So the batching system is still the best we have, but even this very good system has its issues. One of them being that not every conference can afford the manpower to actually award these badges. So you need quite a lot of people to actually perform these experiments and award these badges. And on the other hand, even if papers have these badges, the results can still suffer from low robustness, meaning that for a little change of the input data, there might be vastly different outcomes. So to solve these issues, we try to tackle these from 2 different angles. So we want to first limit the effort that needs to be spent on reproducibility. So we want to reduce the amount of work that either artifact evaluators or other researchers have to actually create the results of the experiments. And we want to make the reproducibility an integral part of the experiment design. And therefore, we want to create an automated experiment from setup over execution to the evaluation of the experiment. And we also try to fix the issue of low robustness, and this we want to fix with documenting all the relevant parameters for an experiment. And we also want to limit the amount that needs to be spent on the documentation, and therefore we want to also automate the creation of the documentation of an experiment. And this we try to tackle by doing a well-structured experiment workflow that also serves as the documentation for the experiment. Therefore, we created the plain orchestrating system, or short POS. POS is 2 things. First of all, it is a testbed management system, and second, it is a well-defined experiment workflow. It works as follows. So here we see a network of 3 nodes. One is the controlling node that manages the entire experiments, and the load generator and the device under test are the experiment nodes that execute the actual experiments. We try to automate all the things that happen in this network over the experiments, so we want to automate the entire configuration and setup phase, the measurement, and finally the evaluation. And therefore we use only live images. Live images have 2 advantages. First of all, researchers must document the configuration they're using for an experiment, otherwise they won't have any configuration at all because they are live images. And at the same time, we don't have any residual state in between reboots. This means that after a reboot, we always start from a clean slate. Therefore, the experiments executed in this setup become repeatable because we automate all things and always start from the same state. On the other side, also other researchers can easily recreate these experiments because if they have access to the testbed facility, they can just execute the experiment file and will get more or less the same results as the original experiment. How does it work in a little bit more detail? So here we see the 3 phases of our methodology. First of all, we start with a setup phase where the controller pushes the images to the individual nodes, in this case the device under test and the load generator, and these 2 then execute the setup script, and these setup script can be parameterized using variables. After the setup is finished, we go over to the measurement phase. There also a measurement script is deployed to the experiment nodes, and again this Measurement scripts can be parameterized using so-called loop variables. These loop variables change with every iteration of the measurement script. So for instance, if you want to measure for different packet rates, you define a list of different packet rates, and for each iteration of the measurement script, a different packet rate will be chosen. So this has an important advantage. Now we know under which circumstances certain results were created, because the testbed knows the loop variables that were active at this point in time, and this can then be used for experiment evaluation. So we know which packet rate was used and can then aggregate over this data. And finally, we can also use this very clear structure to bundle the experiment as a GitHub repository or create a website documenting the experiment. So to conclude my talk, I presented POS. POS is two things: a testbed orchestration service, and second, a experiment methodology. This methodology provides, on the one side, repeatable experiment, because everything is automated. We create reproducible experiments so others can easily repeat the original results. And we finally provide documentation for others to replicate our experiments. So POS, all in all, reduces the effort to create reproducible experiment, but POS does not replace the original ACM awarding system. It just complements it and makes it easier to actually execute the reproducibility in experiments. If I piqued your interest, you can try out POS for yourself using our VM that we provide as a service for other universities. And we also provide an example experiment as a repository and a website that documents the actual experiment results. So thank you for listening.